Hello all. After a long time, I was actually playing with the 3x3s and the 4x4s. After the 5x5 and the other harder ones, I'm not doing a lot of 3x3 or 4x4. So I was actually doing a 4x4, and suddenly I stumbled upon the another type of parity that came through. I was a bit surprised when I remembered I did the edge parities where this is the edges flipped, the edges swapped, and also in the 3x3 when you will see the corners and the edges, which is actually the 5x5. If you see this, if you want to have only one piece moved opposite side, that's another parity, which is probably closing the edges. When we do the last one, there may be a chance of having this. So I remember that those are the only ones that I covered, and after that I also covered the other one where the middle, the actual middle layer itself, for example, this I'll take a solid one. So this, if it is inverted, flipped and then swapped, that's generally rare, but it happens, and we have seen that happening. So that was another one that I added, but this I don't remember adding it, so I thought I'll spend some time and do it. So this happens in a 4x4, not so frequently, but it is it happens because the pieces, there are two pieces into it. It happens, excuse me, it happens in 4x4. It will never happen in a 3x3. Generally the 3x3, you can have a opposite flip, but you will not have a edge swap, the adjacent edges. At least to the extent I tried, in fact would have seen all this scrambling, right? I was trying to see if I can recreate this multiple times, and I couldn't recreate it so far, and I don't remember seeing it in 3x3. But what I'm going to do now is have this clip for the edge parity, which is in 4x4 and 6x6, which we get where the adjacent edges are swapped. So I'll tell you how to swap it and how we can create it also, and then again how to swap it. So that way you'll be able to do it and also make sure that you are able to solve it. So keep in mind, in this case, the edges will not be flipped. They are in the right, side. They'll be facing the right. The yellow will be on the top, and the orange will be facing you. Similarly, green will be facing you, but yellow will be on the top. So it only swaps. If it swaps, then we need to translate this into a three phase. See, ideally what happens is, if you keep something like this, if you remember the advanced C cube, advanced CFOP method, where we have the 3x3, I was telling about the technique where this edge will be rotated here, this edge will be rotated here, and this will be rotated here, whereby in one or two moves you'll be able to get all the four, because the mixture is like this. But in this case we cannot do that, because essentially it is going to bring it back. So what we do is, we have to get this into a edge swap. I'll show you how to do it. So if you get a swap, edge swapped like this, first you need to keep it in such a way that the incorrect edges that are actually flipped is on the 3 o'clock pattern, one here and one here. So keep it like this, and then you do the same formula that we do for a edge that is swapped. For example, if this edge comes here and this edge goes here, you remember we used to have the UU and 2 times UU and then 2 times RR, which is like UU 2 times RR. We'll do the same thing here, and you will see it translates into a 3 edge swap. Instead of the 2, it will become 3, and then we can use the advanced CFOP method to solve it. So I'm going to do that now. So keep it on the top, which is 3 pattern, 3 o'clock. In a clock, if you see this is the 3 o'clock and this is 9 o'clock. So this is a 3 o'clock where the edges are swapped. So you'll have the 3 o'clock, and then do the following thing. UU2, then RR2, then the capital U 2, and then this layer, the third layer alone, R2, and then again the capital U2, the top layer, and then do the UU2, RR2, and then do the. Now you see this, it has actually translated the 2 edge swap into a 3 edge. So the 3 is actually swapped, and you will see that it has a cyclic or a cyclic pattern. So if you move this here, and this here, you have solved the cube. So if you have adjacent cube swaps, parity, you need to translate it into a 3H, and this is anyway solved. And from here, if it is anti-clockwise, we use the F2 URLI pattern. So if you are not familiar, you can go through the advanced CFOF method where I have put the formulas there. So what you do is, after you get this, you have to make a anti-clockwise rotation from here to here, here to here, here to here. And if you see that it is the other way, where the red is here and green is here, and the in that case the red has to go here and the orange has to come here, you do the clockwise pattern. That is also a similar formula. So here it is an anti-clockwise, so I will do a you can do two clockwise anyway. So if you want to do the two times, it will be the same, but one time anti-clockwise will do it. So now in such cases, you need to do the F2 U L prime R F2 L prime R U2 L prime R F2 L prime R U F2. So you see that this is solving it. So I have put the formula. It is a straightforward formula. You just need to do it two times, and I have given it in the description of advanced CFOF method. Please look at it. And this I will just continue with one more small clip. It's like 6 minutes. So I'll take another clip and I'll explain you how to create that parity. So that way you will know when you have this is how we solve it. So I'm going to, in the next clip, I'm going to explain you from a solved cube how to create the adjacent edge parity and then solve this. So we will be able to understand it better. It is just the same steps. You do the reverse of this, and then you will get the parity, and then you solve it with the solution that we know that we just did. Okay, so with that explanation, I'm going to take up a small break and come back with showing how to create that parity and solve it. Thank you.